Right now, we are observing the traces probably left by a crown of thorns based on the combined data provided by the Shroud of Turin and the Sudarium of Oviedo. In the long history of the shroud studies, much has been said about forensic science, textile analysis, and also about physical, chemical, and biological aspects, among others. Yet, one path remains largely untrodden, the mathematical path. Today, I propose we open that path, not an appendix to traditional approach, but as a key to something deeper. What if geometry could expose correlation? What is the pattern we thought random were, in fact, mathematically aligned? The stain we see may be more than traces. They may be projection of a single structure imprinted on two cloths. The 3D sequence you are about to see is not just an animation, it's a proposal, a hypothesis in space, a gesture of trust in mathematical as a silent language, one that listens to form and seeks through a structure, not assertion. Sometimes the Greek answer don't speak, they align mathematically. Good afternoon. Before I dive into my presentation, I would like to express my gratitude to the organizer. It is a real honor to be part of this forum and to share this space with a global speaker and researcher. To be here today is not only a privilege, but also a responsibility to bring something meaningful to the table and learn from each other. I know my English isn't as good as I'd like it to be, but I worked hard to be up to the standard of this event. And I truly appreciate you understand. You help me. Communication isn't about perfection, it's about connection. This presentation will be divided into three parts. First, we will develop a three-dimensional model of the traces left by possible crown of thorn, connecting by blood stain from both the Shroud of Turin and the Sudarium of Oviedo in that specific anatomical area. Second, I will present preliminary results based on morphometric analysis within the context of my second doctoral research, which support the hypothesis that both the Shroud and the Sudarium cover the same head. Finally, I will introduce a new hypothesis, presented here for the first time, the presence of bandages that may be being used to secure the Sudarium of Oviedo to the head of the deceased. In this slide, we ask a key question. If the Shroud and the Sudarium cover the same head, can we extrapolate its three-dimensional structure from the state left on this cloth? I wish everyone had seen my first presentation, where I demonstrated the high mathematical correlation between the two cloths based on a rigorous mathematical study, because this is the continuation of that presentation. The phases of this research process are followed. First, we selected and functionally modeled the point of interest in the occipital area. During this analysis, a hypothesis of geometric coincidence emerged between the forehead area and the occipital one. The Sudarium has fewer defined points on the forehead. Therefore, we incorporated those found in the Shroud by superimposing and aligning the point from the occipital area of the Sudarium. Thanks to the point cloud in the forehead of the Shroud, we completed the three-dimensional structure. In the fourth step, we performed the spatial extrapolation estimating and depth of the selected point. And finally, all the data, we combine it into the unified 3D projection. Here, we focus again on the forehead and the occipital area, where most of the wounds are compatible with the puncture injuries, possibly related to the structure resembling a crown of thorn. In this slide, we saw the study zone used to extract the selected point from both clouds. At the top, we see the forehead area, and at the bottom, the occipital area. On the left are the images from the syndone, on the right, those from the Sudarium. These four regions are the basis for selecting the relevant coordinates that will help us build the 3D structure. In this first image, we see both area of the Sudarium separately, the reverse side on the left and the obverse side on the right. Both are shown using grid at the same scale. No. Both are showing using grid on the same scale to preserve proportional accuracy. This now allows us to superimpose both sides of the cloth, inverting the obverse side so the anatomical zone align properly. In this way, we can select the matching point, or those they are comparable and clear enough to define a functional point cloud that will serve as a basis for the 3D extrapolation. After the superimposing, the points selected have been plotted on a Cartesian system, and we observe a strong parabolic correlation. As you can see, the fitted curve aligns very closely with the data, with R-squared value of 0.718, indicating a meaningful correlation. This curve is fully comparable to the one observed in the occipital part of a human skull. This is a striking match, not just a coincidence, it is a truly striking. Now, we present the forehead area of the syndone, with a marked 16 stain detected and supported by the ISO line, shown in the upper image. They are placed on the Cartesian grid, so we can measure their position with precision. This step helps estimate the depth of each point. It is the final step before building the full 3D model, step by step, while connecting the dots. Okay, thank you. We now show the 54 selected stain for the unified point cloud. Each one is placed on its corresponding Cartesian axis. This layout lets us compare both clouds with the same spatial. There are mathematical results, not at a conjecture. We have inverted the forehead area of the shroud to match its real position on the body. Now, both point clouds are aligned with human anatomy. This step is essential to a precise geometric comparison. We are finally looking at things from the right angle. And finally, step by step, the unified point cloud is taking shape based on projection in Cartesian planes. We have combined the stain for the forehead of the shroud with those from the occipital area of the Sudarium. Now, they are shaped the same reference to proceed with their 3D extrapolation. And very important, every point from the shroud is matched with the Sudarium and the other way around. Piece to piece, the puzzle is falling into place. We can project it onto a human head model, and when we do that, it fits like a glove. What stands out is that this occipital parabola closely matches the natural curve found in human skull. So, we begin the calculation of spatial extrapolation based on this anatomical match. It's not coincidence. The pieces are falling into place. Here we have some photos in Professor Miñarro's workshop. His sculpture of the lion body based on both the shroud and the Sudarium, and his anthropological studies give me a solid anatomical contrast. However, this is something I always do after completing my own calculation. I will now show you a 3D scan of that sculpture, and finally, I will compare its measurement with the data from my study. The results are highly surprising. They go far beyond what we expected. Once the point cloud has been placed in space, we also define the 4 main boundaries on the study area. This allows us to provide accurate spatial projection, making sure the data fit into a consistent and well-defined structure. From this point on, we move into the most complex part of the study, mathematically speaking. Unfortunately, I won't be able to go into very technical detail, and I do apologize, but I'll try to highlight the essential in a clear and simple way. To illustrate the process, we use a 3-dimensional model of the band of the Sudarium and the Sudarium developed by Dr. Peinado. And this joist is not arbitrary. It has a very solid scientific foundation, which I will explain a bit later. Right now, it's important to understand the method we are going to apply to calculate the z coordinate, that is, the spatial depth of each point. Sorry. To do this, we use a real reference point and distances taken from an atoll male skull. Then we extrapolate the values using a technique called parabolic regression. In other words, we state the position of the stain on the cloth and let geometry do the talking. Stay calm. The worst part is beginning us. The beautiful part is coming now.
Let geometry do the talking.
Now, we take another look at a point cloud in space, the one introduced at the beginning of this presentation. But this time, we'll observe it from the 4 main perspectives to better understand its 3-dimensional structure. We'll start with the rear view and gradually move around the left side. This way, the structure doesn't just appear, it begins to speak for itself. Now, we move forward to the frontal view. Next, we move to the right side view. And finally, we return to the rear view. It's beautiful. If we assume that this wound were caused by crown of thorns, this would be the visual outcome of the distribution of the skull. We believe this visible perimeter would be the same whether the crown has closed cap shape or not. Most likely, what we see is the area where the crown was tied with the core to hold it firmly in place. In this simulation, we use a traditional crown, but only for visual purpose, as is a fit to calculate perimeters. The top view. Left side view. The frontal view. And finally, the rear view. After calculating the point class measurement independently and comparing them with the dimension obtained by Professor Peinado, using his own three-dimensional anatomical model, we can see that the results are remarkably close. Even though the methodologies were completely different, the deviation between both models is practically insignificant, 0.19 centimeters at the back and 0.31 centimeters at the front. This gave us a relative error of less than 2%, which strongly supports the geometric consistency of our model and validates the mathematical procedure we applied. This external confirmation gives scientific credibility to the three-dimensional model we have built step by step. The numbers speak for themselves. On this slide, we conclude the first part of the study, and we close it by showing the most meaningful result, a dimensional match that validates the entire geometric and mathematical structure we applied. And this proportion fall within the range recorded in archaeological studies for Mediterranean site. And now, we move on to the second part of the presentation, which is more about the future than the present. In this section, I will present some of the ongoing processes, most of them part of my second doctoral thesis, which I'm currently developing at the University of Oviedo in Spain. This work focuses on the mathematical model of structural coincidence between the syndrome and the Sudarium. This part deals with morphometric analysis, a field that studies shape and structure using quantitative methods. Its novelty, in this case, is that for the first time, this approach is being applied to the comparative analysis of the anatomical stain on fabric surfaces. This allows a geometric, reproducible, and objective evaluation of their similarities. In a very simplified way, this is about displacing market to online the shape of the object, so we can compare it with others that might be or represent biological, archaeological, or anthropological elements of the same kind of species. For example, to find out, however, the remain of a fish belong to the specific species. Same pattern, same history. Now moving into the more complex explanation. I truly regret having to show something so disturbing, but something we must face the implicit trust to move forward in our research. The morphometric approach are developing basis on four completed pillars. First, the computational geometry, which helps calculate center of masses, symmetries, and apply geometric transformation to the stain. Second, multivariate statistics, which use to analyze shape correlation and to compare the structure using numerical metrics. Third, data science and visualization to represent complex information from the syndrome and the scenario in 3D model, isoline, and color map. And finally, geometric morphometric focuses on the analysis of contour and deformation processes to quantify shape similarity and detect areas of high depth variation. The value of the approach is that it doesn't just measure distances. Two structures can share the same dimension and still be completely different. That's why this method looks at the shape itself, not just how far things are, but how they are formed. But if they are oriented differently, they are not likely to share the same origin. Morphometrics help us to see that it's not just about how close they are, but how they are arranged in space. We begin now with the center of mass, a classical concept for physics, which be adapted to image analysis. In physics, the center of mass is found by using physical meshes distributed in space. Here we apply the same formula, but instead of masses, we use the pixel intensity values from a digital image. So, in the end, we have a geometric balance point for each cloud point. Here, we see an example of a superposition between a stain from the syndrome and the Sudarium. The result gives us a geometric center, green for the syndone and blue for the Sudarium. Even with the image magnified, the visual proximity between both centers is clearly noticeable. Later on, we will take a closer look and quantify this closeness. If we now make a methodological shift, we calculate the intensity center, not from individual points, but from entire image areas, with a surprising result in the occipital area. Here, we see the center of mass of the blonde stain surface in the shroud and the Sudarium. They are perfectly consistent with the visual distribution we already observed. This calculation was done to validate the method using surface, not just individual point. It's another way to double-check the history the stain are telling. Be very carefully, not to confuse hypotheses with conjectures. At Terices, we don't make conjectures, only hypotheses based on science. If we calculate the geometric center using each individual point as a reference, we end up with 8 different centers in total. In this slide, we saw 6 of them, all located in the forehead area. They correspond to the result based on point 1 to 6 as a region of coordinates. Here, we can see the global center of time, that is, the average of the 8 geometric centers, each one of them calculated for a different reference point. In green and blue, you can see they are very close to each other. This tells us that the distribution of a stain is highly consistent and that our model is reliable and stable no matter which starting point we choose. And in the occipital area, the global mass center shows the remarkable alignment. This matches the even distribution of the stain on both cloths, right in this part of the head. This closeness between both centers, as you can see from the displaying vector, confirms a high-level geometric consistency in the whole structure on this area. Now, we move on to the analysis using inertia and ellipses in the forehead area. This method gives us a compact way to represent the orientation, the overall shape, and the spread of a point cloud. As you'll notice, this method gives us a clear geometric picture and allows us to compare shapes objectively, even when at first glance they may look quite different. And now, by projecting the inertia ellipsis data onto the occipital area on the 3D model, we can once again confirm the structural consistency between both cloths. This is the matrix of deviation. This is science. This is not conjecture. Naturally, to align the stain correctly on the model, the position must be flipped horizontally. That's because we are moving from the imprint left on the cloth to its true anatomical position on the body. And with the adjustment, the matching shape, orientation, position is truly remarkable. We now move into the procrustics analysis. In simple terms, this method aligns two sets of points and check how similar they are in shapes, no matter the size, position, or rotation. On the left, you can see the result of the occipital area. On the right, we see the same analysis for the forehead area. Here, the graph shows how close the point on both cloths really are. But what's truly overwhelming are the numbers, and the numbers don't lie. The value we obtain is called procrustics disparity. The closer it is to 0, the more similar the shapes are. In this case, the numbers are extremely low, 0.0143 for the occipital area and 0.0176 for the forehead. This confirms a very strong structural match between the stain and both cloths. The numbers speak for themselves. The shapes are virtually identical. We finish with the Mahalanobis distances. We place on trust in the number. They speak louder than words. It's measured how similar two shapes are by considering their form, spread, and direction. Unlike the Euclidean distance, it doesn't treat all directions the same. It's adapted to the inner structure on each group. In our case, the results are clear. 1.42 in the forehead and 1.1 in the occipital area. The values show a strong geometric match. Looking at it point by point, all values, SS1, are well below 1.51. Only one point is slightly above this line. This confirms the overall consistency of the model. Here I'm showing some results that, due to the time constraint and because there is still a work in process, I have been able to fully include in this presentation. But they are part of a much broader analysis. This journey has only just begun. And I truly hope to come back soon to share the full story, preferably in Spanish, or unless or much better English. I close this part with the inverted V. Perhaps the graphic and mathematical paradigm on both that I've given at this Congress. We see its raw heat map and isoline, two lines of analysis that, honestly, I deeply regret not being able to explain with the time and depth they deserve, because I think really beautiful. In the isoline, we can trace the more accuracy point of the bone, the path of the blood, and its accumulation in two directions, consistent with the different inclination of the head, and with that we observe in the Sudarium. For me, this is breathtaking. To sum up, considering of the above mentioned methods, today and Thursday, mathematically, we can hold that the syndrome of Turin and Sudarium of Oviedo cover the same head, cover the same person. And I will move on to the last part of this presentation, a proposal we've been working on over the past few months. As part of my doctoral research, we started applying transformation to the images of the raw, focusing particularly on the facial area. We generate heat map based on image intensity and isoline. Based on that same intensity, these levels were divided into decile, that is, in a step of 10%. This allows us to analyze the distribution of relative intensity across the image with a much greater precision. We applied the same process to the Sudarium of Oviedo, but during the intermediate step, we noticed something interesting. In the threshold image, organized by intensity level, we saw that the sensitivity was reduced little by little down to the lowest threshold. The areas of highest intensity began to emerge gradually and clearly. This behavior allows us to detect new patterns that were not visible in the original intensity maps, patterns that may correspond to point of pressure, blood accumulation, or area of more direct contact with the face. Later, during the multi-level thresholding stage, this formation remained clearly visible. The same pattern is observed again and again in every single test. And we saw before the region with the highest intensity match, the area of stringent pressure, most likely cause for bandages that hold the cloth in place. Well, several of these formations can also be seen in the scan of the Sudarium. Some of them are just fall in the fabric, but others, like the ones we saw here, include extra point of blood accumulation when this is still fresh. This is still in an early phase of study, and we are currently conducting experiment. However, preliminary survey suggests the following. The bandages appear to have been focused around the nose and the mouth area, like involving a single band wrapped around that thumb. The bandages may have been put on and then removed when the Sudarium was unfolded, and later put on again. This could explain the presence of multiple linear trajectories. We believe the upper lines are not the result of bandages, but rather of the folding of the Sudarium, possibility caused for the knock or even without it. In short, the presence of bandages seems highly probable. The pressure, they asserted, would have been necessary to stop the flow of the blood and other fluids, and this is crucial because there are no smear in the Sudarium. The same structure can be observed on the forehead area. In the heat map with isoline, the accumulation remains visible, suggesting the possible presence of an external linear source of pressure. This kind of pattern could be very hard to explain without some physical constraint, like a band holding the cloth tightly against the face or the skull. As we can zoom into area, we detected several points where we pressure that fluids accumulated, possibly due to the action of the lining bandages. These accumulations are not random. They seem to follow a consistent pattern. Sometimes the small detail can change everything. We mark some of these points in this area, as they are among the most significant. We believe that this accumulation formed while the body was lying face down for obvious reason, because that's the only way fluids could have flowed apart toward the top of the head. In the zoom in, for example, on the occipital area, we can observe it clearly. And the same applies to the central area around the mouth and nose. And by the way, we are currently working on detecting possible pattern of the shroud and suggests it's what fastened with the lining bandages. We are analyzing all photographs. This one, for example, was taken by Vernon Miller. Why all picture? Because in the post-restoration image, most of the original wrinkle almost vanished. In fact, the loss is quite significant. So you are going back to the early sources. Sometimes they move forward, you have to look back. We must be cautious here. This is only a working hypothesis. And for now, we are only considering some possible indication, not solid evidence. We believe that the lateral wrinkle might correspond to pressure some created by bandages used to tighten the shroud around the body. But this idea still needs further testing. At this stage, we're just observing patterns that seem to fit, but cannot yet be confirmed. However, from the study of the blood stain, especially in the elbow area, we don't believe that the cloth was folded laterally over the body and then tied with bandages to hold in place. Let's not jump the gun. We'll keep exploring carefully on clue at a time. To conclude, I will show two videos. I will show two videos of the simulation they carry out using cloth replicas of the Sudarium in Professor Miñarro's workshop. If the shroud is a scientific mystery, a challenge to our intelligence, especially in this century, then the Sudarium is a confirmation of real events. It is, above all, the clearest clue to understand John 27 and give it real value to that passage, something we shouldn't overlook. The Sudarium is still a great unknown, and since yesterday, I see it more clearly. But it multiplies the value of the shroud and the water haven is the tomb of Jerusalem. It's an old, wrinkled, and stained cloth. A cloth what had passed through history without being fully understood. And today, it's still like that. And maybe because of that, it's even more value. We don't fake what we cannot understand. For me, for our team, it is the piece that makes sense of everything. Through science, through its quiet journey through history, the Sudarium now emerged to support what we believe about the shroud and about the event that brought Peter and John to a tomb and seemed empty, but was full of information. To God, one message. Everything we just present is not a set of final conclusion. It's just a piece. One more piece of much larger puzzle, but not just any piece. It's a piece that fits perfectly. And by doing so, I help all fall into place. There are still many work to fill, many questions to be answered. But I keep trying with the tools the mathematics give me, and with the conviction that each connection is a step toward a clear picture. A picture that together will keep building in search of the truth. Let's keep digging until the whole picture comes to light. Please, no conjecture that aren't supported by science. We may be strong, but if our theory is incorrect, it must be proven because mathematical support us. Thank you very much. It's been an honor.
We have time for maybe one or two questions at most.
Thank you very much. Two quick things. Perhaps later this evening after dinner.
My friend
Oh, yes.
Fernando,
Yes,
this moment.
Sure. Two quick things. Perhaps later this evening after dinner. I'd like to show you a short 19-second video that I think would confirm some of what he talked about in section 1.
Quiero enseñarte después de comer un video que confirma lo que está diciendo.
Thank you very much.
Yes, and then there's a great, seemed to be a great.
Que confirma que de las tres cosas que.
That confirms the points que tú estabas haciendo ahí.
Pero qué parte
Which
de
one?
ella.
Which one? He wants to know.
Which part? 1, 2, or 3?
One.
One. Okay.
And then secondly, there seemed to be a very cautious, great hesitancy in talking about the shape of the crown. You said just for reference purposes, we use the circular crown and didn't talk about whether it was circular or helmet shaped. But can you say anything about the final shape of the crown that would have formed those wounds?
Una capa o...
Sí, ya, pero eso es muy importante, creo que lo he dicho y me gustaría que lo remarcase.
Sí.
Que lo que se ha estudiado matemáticamente,
yes, it's
the
very
study
important.
mathematically is not the form of the shape of the crown of the thorn, it's the trace in the head, only the trace in the head. The trace in the head, it's a perimeter.
Yeah.
It's a perimeter only. There is a consideration of the cap or no cap. Okay? It's anatomically.
Yeah. They took what they did. They just took the area like a crown to study as part of the study, and it matched perfectly. But they didn't go into like the cap. Yeah.
Okay, we'll stop there. Oh, did you have?
Yeah, we'll be around.
They'll be in the back, in the hallway if you have any other questions. Thank you.
Muchas gracias, Fernando.
No, pues nada, muy bien.
¿Sí?
Después de tanta cosa, me alegro que tú me pasaste